Okay, it says the battery in the given circuit has a negligible internal resistance. The potential variation around the circuit when the switch is open is best represented by switch is open. Here's a ground connection. So where you have a ground connection is where you have 0 volts potential, right? So there is no current. So here also we have 0 volts, and here when you go from minus to plus, what is the potential here? What is the potential at A? V naught plus V naught, right? Plus V naught. So here also it's plus V naught. And what is the potential at C?
It has to be 0.
Why 0? So think about it. Now, do you have a current in this? No, we don't have a current in this, right? So when there is no current through a resistor, does it have a potential difference? No potential difference. Right? So if there is no difference, what you have on this side should be on the other side also. See, simple theory. So it's V naught. So it changes from 0 to V naught at F. So E and F, it's 0. At E and F, it's 0. And at A, it's going to be plus V naught. Right? And then continuously plus V naught. Right? Plus V naught continuously. Understood? Right. So E and F 0 plus V naught. So it's answer 3. Answer 3.
So if it was closed, then how would it be?
Good question. Right. We'll try to do that almost. So it is closed. Right, let's close it and see. So there is the circuit has negligible internal resistance. So the battery given circuit has negligible internal resistance. So we are going to close the circuit. So if you close it, if you close it, there is a current, ne? So here is 0, here is all 0, and there's no internal resistance. So here again it will be V naught plus V naught. Here also plus V naught again. Then, and you know here it's 0 at E, so at D also it's 0. So here also it's 0. So whatever the potential that you provide to the circuit will be used in the resistor given. Okay. So at A it will be V naught. At B it will be V naught. So A here, B here. But at C it will be 0. D, E, F, everywhere it will be 0. Understood?
Alright, okay.
So here it's 0, right? 0 volts. So current is 2 amperes. So what is the potential here?
Plus 10.
Plus 10. And here also plus 10. So we can mark it like this. 0 constant here increases to plus 10. So and plus 10 retains. So it's plus 10. All right. What is the potential on the other side of the cell?
So it's plus 11.
Plus 11, yes. So you may wonder how. So what you have here is a resistor and a battery. So battery is 1 volt and the current is 2 amperes. Resistor is 1 ohm. So here it's plus 10 So when you go to the other side, it's the minus side, so it reduces by 1, so it's plus 9. And when you go from here to here, there is a potential increase because current goes from higher to lower potentials. So through a resistor, right? Resistor, so it increases by another 2, so it's plus 11. So here it's plus 11, right? So what do you have here?
It has to be plus 17.
Plus 17. And right, what do you have here?
So it's going to be the same potential.
Same, no change. Right, why is that? Because here you have plus 17. Here the battery is 10 volts and this is 5 ohms. So here is going to reduce by 10. So it's plus 7. The current is 2 amperes. Now it's going to increase by 7 when you go from here to here. So it's again plus 17. So no change. Plus 17 it is. No change. Plus 17. And the third cell.
17. Sorry, 13. Sir.
13. Let's check. So it's plus 17 here, and the battery is 8 volts, so it's reduced by 8, so plus 9, and this is 2 ohms, 2 ampere current, so it's increased by another 4, so plus 13. So from 17 it drops to 13. So we have 0 here. 0. So we'll go to this side on the left hand side. Zero current is going towards this side. 3 amperes current we know goes from higher to lower potentials through a resistor. So it's a 2 ohm resistor. So its potential difference is 6. So this has to be 6 volts higher than the other terminal. Why? Because current goes from higher to lower. And it's 8 volt battery, so it has to get increased by another 8. So it's plus 14. So you got plus 14.
Yeah.
Right. So it immediately increases to plus 14. And the other cells. On this side it's 0, 10 volts battery, 5 ohm resistor, 3 ampere current. So when it's 0 here, what you have here is plus 10, and it drops as current flows. It drops by 15. So it's minus 5, ne? Minus 5 hours.
Oh, sir.
Then the third cell, -5, 3 ampere current, 2 volt battery, 1 ohm cell. So here what you have is -3. Here what you have is -3 reduced by another 3, -6 there.
Yes.
Right.